A Sentinel value is simply a value that is used to terminate a while loop. Sentinel values are used so that the user can demonstrate when they are done entering values. It allows our loops to be the size that our users need them to be. And it's typically something that is not a valid value, but it does need to be the same data type. For example, we may have a program that says enter positive numbers, so a Sentinel value to end the loop could be -1 because it is a number, but it's not a positive number. Another example is enter a name, and a Sentinel value could be done or end or quit, because I've never met a person with the name done, end, or quit. But they are of the same data type as well. The name would be a string, and done, end, or quit would be a string. Let's take a look at some examples in Java. In this first program, we're going to collect test scores until they enter in the value of -1. So our program will come in here, ask them to enter a test score, and we'll capture that test score into the integer variable score. We'll use that value to start our while loop. So we'll say while score is greater than or equal to 0, we're going to execute this while loop. The first thing we do is we take score, we add it into total score, and store that new value back in total score, and then we'll increase test count by 1. Then we ask our users to enter another test score or -1 to exit. And we'll grab that new test score inside of our existing score variable, and that new score value will be what we use to evaluate our loop. So as long as it's greater than or equal to 0, we're running our loop again. But if it's not greater than or equal to 0, we're exiting out of our loop and we're printing out our test scores and the average of our test scores. To see this loop in action, we'll begin by entering a test score. And it first checked to see if that first test score was less than or equal to 0, or was less than 0, and it was not. So it continued in through our loop, it captured that value, that 22, stored it into a total score, increased our test count by 1. Now we're being prompted again to enter another test score. When I'm finished entering test scores, all I have to do is type -1, and that is going to store that value inside of score, and it will go up here and we'll see that this condition turns to false and will exit outside of our loop. So note that -1, even though we've typed it in, will not be scored or added into total score, and it will not increase the test count by 1. You do need to pay attention to the order that you have your prompt and your request inside of your loops. If I adjusted this loop so that those values happened at the end, the addition of the score to the total score and the increase in the test count, you would find that I would be missing my first value inside of my score going into total score. So I'll run this here. We'll give the test a first score of a 99, and then we'll add in another one, 22, and we'll go ahead and exit. And you can see just the value of the first one went into counter variables, and it actually decreased the score by 1, and only 2 scores were caught. And the one that was caught was the 22 and the -1. So the 99 was never even acknowledged. We need to pay close attention to the order that things are happening inside your loop so that you're getting accurate variable counts and accumulators if you use them in your program. Let's take a look at the second example. This example uses a string as a Sentinel value. It asks us to enter in a family name or end to exit. We capture that name inside of the name variable. We just have a simple counter variable that allows us to count how many family members there are. And our while condition says, while name equals end does not equal true, then we're coming through our loop. So it's a little backwards because there is not a method for not equals. We have to use our operators instead. So while name does not equal end, we're going to increase family member by 1, and we'll prompt and ask for another family member until they enter end. So again, we grab that value into name, and we jump up here and we perform the check again. As long as name does not equal end, we're going through our loop again. Once name does equal end, we're exiting out of our loop. Now remember with strings that capitalization does matter. So if our user typed in capital E, ND, that would not equal end because this is all lowercase. I can account by that by either using the equals ignore case, or I could send name to uppercase or to lowercase. Let's watch this program run. Again, where the family member count increasing, that does matter, so you need to pay close attention to the order of things happening inside of your loops. Again, end is not being captured as a family member name, so that's why we only have 3 members of our family. Just to again point out that capitalization does matter. I've typed in end and then in all uppercase, and it does not match end in all lowercase, so the loop did not end. Another way that you'll commonly see this written is, rather than using the does not equal true, you'll see using the exclamation point with it at the beginning of the evaluation. So this does the exact same thing as this line, except it's shorter, and this reads basically as well long as name does not equal end. So we don't have the does not equal true here, because this will either evaluate to true or false, and that will make our condition for our while loop true or false and allow us to exit or continue through our program. Let's look at an example where we have a data type mismatch. In this program, I've asked them to enter a test score, or end, to exit. So I'm capturing the test score into an int variable. However, end is a string. So whenever I run this, I have no problem entering in test scores, but whenever I type in end, I'm going to get an input mismatch exception. And that is because inside of score, we are waiting for the next integer to go in there, not the next line. So we need to pay close attention to make sure that our Sentinel values match in their data type so that we don't end up with an input mismatch exception. Our final example here uses both strings and integers. This one, we are capturing a family member's name, and then we're going to ask how old that family member is. This is a little tricky because we haven't worked with loops and capturing both an integer and a string type of variable from the scanner line. So we have an extra line that we need to add to make sure that we're clearing out the old line break after grabbing an int off the line. So in this while loop, we're going to run this program as long as the name doesn't equal end. Once we capture a good family member name, we're going to ask how old that family member is, and we'll store that into our age variable. We'll take age and we'll add it to total age and store that value back into age. And then we're clearing the next line so that we're able to get the next family member name off of it, grabbing our name into our name variable. Go ahead and run this and enter a family member's name. It does not equal Ann, or it does not equal end. So it continues on, and we'll answer how old Ann is. Enter another family member name. Now I've entered end, and it will go through there, check to see if name equals end. It does. So now we're exiting out of our loop and performing our calculations. Now without this next line in here to clear the extra line from grabbing the int off the line, we actually end up with kind of a mess. Notice that it says enter another family member name or end to exit, how old is question mark. So the question is it expecting a string or a double? It was expecting a double. The way that we avoid that is just to keep in our in.next line, and this will clear the line from the integer so that we're ready for the scanner to stop. Be sure to test your programs. Practice makes perfect. Make sure that you're capturing the values inside of your while loops at the appropriate time, and that you're not missing any iterations of values inside of variables as you continue through your loop.